Now we can construct our basic triangle using points x1, y1, and x2, y2. We can put those points any place we like. I just happen to have put them here. And we're going to assume that the x direction is horizontal, the y direction is vertical. So what do we do to figure, to construct our basic triangle? Okay, well, we first draw the segment between the 2 points. Now you ought to have a picture of this in front of you, and you ought to already have that segment drawn before you see me draw it. But fairly simple. We just draw a segment between the 2 points. Then we construct our right triangle, whose legs are horizontal and vertical, parallel to the x-axis, parallel to the y-axis. Last time in the numerical example that preceded this, I drew the triangle here, so just to show that the triangle could go up here. Excuse me, I'll start the horizontal side from this point and the vertical side from this point and bring them to the point where they meet. This will, of course, be a right triangle. Now, in symbols, what is the, and let's talk run and rise now. I could talk directed distance, but I'm just going to talk run and rise since we've talked about what all that means. The run is in this direction if we go from this point to this point, from the first to the second, and that's usually the order we'll think of it in, is what? Well, if we go from one number on the x-axis to another number in the x-axis, if we want to know the distance and the direction in which we had to displace in order to cover that distance, we would subtract the coordinate of the first from the second. For example, if this coordinate is 5 and this coordinate is 10, then our run would be, well, let's say 5 and 12. Our run would be from 5 to 12. That would be a run of 7. And we could get that by subtracting the first, the 5, from the 12. We wouldn't subtract the 12 from the 5. So the run is going to be x2 minus x1. Again, if we think of going from the first point to the second. What's the rise? It's going to be y2 minus y1. Then, what's the hypotenuse going to be? Okay, again, figure this out yourself, but I'm going to go on and hopefully you paused and come up with your own idea here. It's going to be the square root of the run squared plus the rise squared because the run is this leg, the rise is this leg, and if you square the lengths of the legs and add them, you get the square of the hypotenuse. Taking the square root of that, you get the distance. So we have x2 minus x1 squared plus y2 minus y1 squared. And that's the distance between the 2 points. Now, if we want the slope of this line segment, we can easily write that down. The slope is what? And write this down yourself again before you watch me do it. Hit the pause button. Slope is rise divided by run, which equals y2 minus y1 over x2 minus x1. Now let me add that if this point was to the left of this point, then x2 minus x1 would be negative because the x-coordinate here would be less than the x-coordinate here, so you'd be subtracting a larger number from a smaller, and you would get a negative. So these symbolic expressions take care of positives and negatives if you just follow the symbols. Now, I don't advocate memorizing the formulas for the distance or the slope. Slope is rise over run. Distance is the hypotenuse of a right triangle. Those are very fundamental ideas. The formulas come and go. Okay? The idea that slope is rise over run is more likely to stick with you than a formula, and it's also going to give you a deeper understanding of what the formula means rather than just something to plug the numbers into and pass a trivial standardized test that doesn't ask you to think about anything. Okay? So we have basic thinking ideas here, basic thoughts behind the formulas, and they're not difficult to understand. Okay. Now, the other thing is the midpoint, and that one is, I think, really pretty easy to understand. The midpoint has x coordinate halfway between x1 and x2. What's halfway between x1 and x2? Think about that. Halfway between x1 and x2 is the average of the two, x1 plus x2 divided by 2. It doesn't matter if one of these is positive and the other is negative. If they're both negative, ones are both positive. Makes no difference. If you add them and divide by 2, you get the number that's exactly halfway between on the number line. And of course, the x-coordinate of the midpoint should be exactly halfway between here and here, wherever here and here happen to be. Okay, and also well, the y-coordinate is going to be halfway between y1 and y2. So the y-coordinate is going to be, I put a mid there, that's x mid, this is y mid, equals y1 plus y2 over 2. So, the midpoint is x1 plus x2 over 2, y1 plus y2 over 2. And really, if you look at the formula, you see that. x1 plus x2 over 2 is halfway between x1 and x2. y1 plus y2 over 2 is halfway between y1 and y2. Now, if you don't remember the formula, you just draw the picture and ask yourself, what's halfway between x1 and y1? What's halfway between, what's halfway between x1 and x2? What's halfway between y1 and y2? There you have it, and there's your formula. All you have to do is draw 2 points, label the coordinates x1, y1, and x2, y2, and everything else, the slope, the distance, the midpoint, comes from that picture, not from formulas handed down on a stone tablet. Okay, again, I advocate thinking in terms of the picture rather than using otherwise meaningless formulas.